In this video, we're going to set up and run a roll with the thermal cutting on the Vitek profiling software. We're going to do part zeros, set up the thermal cutter, and run a part. So the first thing I'm going to show you is the CAM or profiling software. So you go to CAM, roll, F3. Now that we've loaded the roll grinding and grooving software, we're going to go straight to groove, and we're going to do a spreader. So you can see the spreaders highlighted here, and with those you select the face length, and as I highlighted the face length, the roll diameter, the land width, the angle, and you see that the thread pitch and the number of starts are grayed out. So the number of starts will show up as you change the angle. And then you have the direction, the center width, groove depth, use thermal cutter, tool, tool width, and tool diameter. So if I select use thermal cutter, you can see tool 3 automatically comes up and is grayed out. So we only use tool 3 for thermal cutting. In this case, I've already written the parameters in to save time. So we're going to go ahead and load a program. So now that I've loaded in the part parameters and dimensions that we want to cut for the Flex Spreader, first I'm going to go to Setup. In the Setup menu, we're just going to fill out the variables that matter for thermal cutting, which are the approach clearance, which I've got 100 thou, end clearance, which is 1 inch. I recommend at least a ½ inch clearance to the end of the part. In this case, we don't have any taper, so we don't have any taper measured to put in. And these all have to do with grinding and undercutting, so they don't matter. Then we go back to the grooving. You got the plunge groove feed rate, which is the x-axis. When it plunges into the part, we have it set at 50 inches a minute. And the groove feed rate, which is the actual rate which the groove is being cut with the combination of the Z and the C axis. We have the thermal cutter initial warm-up time for when the cutter starts at the beginning of the program, and then in-cycle warm-up time, which I have 3 seconds, and that can vary. Both of those can vary depending on the cutter you're using and the material. And the tool adjust clearance, which is important because that's the amount the x-axis will move away from the part or the roll in order for you to have the ability to rotate the cutter for the right side of the part. Once you fill in those variables, you go to groove. In this case, of course, we're doing a flex spreader, so we selected spreader, and we're not following a groove profile, so we'll go ahead and have that face length, the roll diameter, the land width, the angle. And notice below the angle we have the thread pitch, which doesn't matter because that's based on the angle. When we have the number of starts, the number of starts will vary depending on our angle. So if we select, say, a 20-degree angle, our number of starts increase to 23. So whatever the angle is selected gives you the number of starts. If you go to a 90, then you can see you have 1 start. But we're going to do a 4-start program, so we're using 80 degrees, 4 starts. And then you have the center width, the groove depth. Then we had to use thermal cutter first in order to get the proper parameters to show up. And you can see we have automatically where it selects tool 3, and you have your tool width. And once those are selected, you go ahead and select F10 Run Groove, which saves the program. You give it a program name, and it automatically loads to have the ability to run. Next thing we'll do is the part 0 setup. Now we're setting up the Z-axis actual part position on the left side of the roll. You can see here I'm changing the axis control knob to Z and the increments to ×10, which is 1 thou increments. And since it's handy, I grabbed a parallel to find the center of the thermal cutter fixture. You see me slide it over, find the center, and then use the MPG and adjust the Z-axis until it is parallel with the roll. Once this is done, I go back into the setup screen and set the part 0 for Z. Now we're back to the main menu of the CNC, and you can see on the very top where it says job name, that's the name of the program that we loaded. And now we want to set up the part position in zeros, so we go to setup, F1 part, and you can see the first thing that comes up is part position Z0 with tool number 3. You want to make sure that the correct tool is selected, and we're going to use part position 0 because we're going to set the cutter on the left side of the part closest to the chuck, and set part position 0 there. Then you select set, and part 0 in the Z is now 0 at that edge of the part. Now we're setting up for the X-axis, and again on the MPG I select the X-axis, and then I bring in the X-axis till it's somewhat close to the part visually. And in this case I'm just using a piece of paper because it's easier than looking and trying to visualize the location, and I bring in the X till it's tight. There, it's tight on the paper, so I know I'm relatively close, within 3 thousandths. And then I go back to the main menu, remembering to turn the MPG off every time, and I select the X-axis part 0. Set X, and you can see part position is 0, tools number 3, which is what we want. And set the current work coordinate system. The current work coordinate system is G54, and that's what we're running. So we just set G54, which is the current one. Part position 0, so we're going to touch off on the part. We have previously measured the part diameter, and so we want to put the diameter. When doing thermal cutting, it is going to be a negative number because we're approaching from the front with the thermal cutter. For grinding, it's going to be a positive number from the back of the part. So we're going to put a negative 9.325, which is the diameter of the part we're getting ready to groove. And then you hit set, and you can see here we're touching off on the part, so therefore we check our numbers, and they're 9.325, and our Z is at 0, and so we should be ready to run the part. So just simply hit escape, and you're back at the menu, and you're ready to hit cycle start. Of course, first you're going to set up the thermal cutter temperature with the thermal cutter control and make sure the temperature and the airflow is correct. And then you'll be able to run the part. In this case, we're going to select graph just to check the part to make sure we entered all the data correctly when we set up the part. And you can see here where the part is showing the diameter. I can zoom in on the part and look closely at the diameters to make sure they match up. I can also look at the z-axis and the length, and you can see the red's rapid and the yellow is cutting. And I can also take a look at the time it takes to run the program, which in this case it's 4 minutes and 34 seconds. This helps you verify everything. So now we set up the part, ready to hit cycle start and start cutting. This thermal cutter is warmed up and cutting its first start, which is a 4-start roll. And each time it completes over the edge of the part and then rapids back, clearance of 100 thousandths. Cutter's warming up now, and then it starts its next pass. One thing I didn't show you is how to set up the thermal cutter, which is in the manual, and we didn't take the time to do that. So the thermal cutter was set up with a remote switch, which is on the fixture itself on the top, but the thermal cutter starts and stops automatically based on your program. Next thing we're going to show you is cutting the right side of the part, which is in the program. Now cutting the right side of the part, the machine automatically stops and backs away. So I've just rotated the fixture and I press cycle start. It rapids back, allowing for the center distance with your program. In this case it was 4 inches. And then starts cutting the right side of the part with the same 4-start Flex Spreader program. Next we'll be showing you how to install and remove the fixture, which is relatively simple. When installing the thermocouple fixture, there are T-nuts underneath it in the T-slots here. Line these 4 bolts up with the T-nuts. Straighten out the fixture, make sure it's lined up with the table, and then line it up with the mark in the back. That prevent you from hitting the guards, and also have enough travel to cut the parts. And using an Allen wrench, an 8mm, tighten bolts. Make sure before mounting the fixture you have homed the machine, because you cannot home it with the fixture in place if you have a part mounted. If you don't have a part mounted, you're fine. If the part's in place, remove the fixture or slide it back before homing it so you don't run into the part. Slide the fixture over here, lock it. Should already be set up on center from the last setup, and you have your on and off switch here to set up your thermal. To remove
the thermal cutting fixture, loosen it, tool holder, slide it off here so it's clear of bolts and also safer. Lock it in, loosen the bolts, remove them. And fixture, so you can leave the hoses hooked up. You just lift the fixture up, and then as you can see, when you do mount it again, you have a T-slot guide here, key, so it'll help you line it in. When you do put it back in, make sure that it's in between the two T-nuts. Slide it off the table. And then you have the option of sliding the T-nuts back out of the way, and I would recommend just putting the bolts in, either keep the threads clean, and it's easier to find them later, and they will be out of the way and locked in place. Now remember, when we're installing it, you may need to remove the wheel off the grinder for clearance, so check and verify all your clearances before operating the machine.